Hi again, and welcome to my second tutorial on linear sequences. In my first one I covered the first 4 questions on here, and now I'm actually just going to do how do you use the nth term to generate a sequence, and how do you use the nth term to determine whether a term is a member of that sequence as well. So before we go into that, just some prior learning. So in order to do this, we need to understand what it means to substitute. Now, substitute sounds just as like when you're playing football or whatever. It just means that you're swapping one thing for the other. So in football, you'd swap one player for the next. In this case, we're swapping the letter for the number that letter represents. So when x is equal to 8, wherever I see x can now become 8 because I'm substituting it, I'm swapping it, and then the rest stays the same, so it now becomes 8 plus 7, which is 15. Equally, 4a, we know that convention tells us to get 4a actually means 4 multiplied. In algebra we put them together when we multiply, so we don't need to write the times sign. So 4a, 4 times a, so when a is 13, that's actually 4 times 13, which is 52. 5n plus 16, when n is 120, so following BIDMAS, you know that we need to multiply first, then we need to add. So 5n, 5 times n, or in this case 5 times 120 plus 16 is 600. Add 16, which is 616. So how do you use the nth term to generate a sequence? Just like we did previously, you just substitute in values for n. So work out the first 3 terms of the number sequence. You would have seen in my first video that n is the position. So the first 3 terms, when I'm talking about my first, second, and third, n is just the position in the sequence. So first n will be 1, second n will be 2, and third n will be 3. So that's what n is equal to. So I'm substituting these values into 3n plus 1. So first one is going to be 3 times 1 plus 1, which gets me 3 times 1 is 3 plus 1 is 4. My second, I'm just going to draw a line so I can separate it so that we don't get them confused. 3 times 2 plus 1, and so 3 times 2 is 6 plus 1 is 7. And then the last one there, my third, is 3 times 3, and it's 3 there, plus 1. So 3 times 3 is 9, plus 1 is 10. What we can also see is that what we can also do is we can substitute the first. So 3 times 1 plus 1 is 4, and we know because it's 3n, it's a common difference of 3. So I can then add 3 to get 7, add 3 to get 10. So either way, 4, 7, 10 is our final answer. Okay, another example. I'll do it just under here. So if I was to do substitute, so find me the first 4 terms of 5n plus 7, I would then start by saying when n is equal to 1, 5 times 1 plus 7, and that is 12. 5 ones are 5 plus 7 is 12. When n is 2, then it's 5 times 2 plus 7. So 5 2s are 10 plus 7, 17. When n is 3, 5 times 3 plus 7. 5 3s are 15 plus 7 is 22. And then the last, because I said I wanted the first 4 terms, first 4 members, so it's n equals 4. 5 times 4 plus 7 is 27. And equally, you could have started with 12 after substituting 1 and then added 5 3 times. So plus 5 is 17 and go on like that as well. Okay, so how do you use the nth term to generate a sequence? And this, we've seen that already. Now we're going to have a look at some special questions. So the first one, the nth term of a sequence is 100 minus 3n. Work out the first 3 terms. So 100 minus 3n means I'm taking away 3 times the position each time. So we'll start with n equals 1. So it's 100 minus 3 times 1. And you know from BIDMAS that we multiply before subtracting. So it's 100 minus 3, which is 97. When n is 2, it's 100 minus 3 times 2, which is 100 minus 6, 94. And it's just 3 less because it's minus 3, just 3 less each time. N equals 3. We only need up to 3 because we want the first 3. So it's 100 minus 3 times 3. So it's 100 minus 9, which is equal to 91. So my first 3 terms are 97, 94, and 91. Okay, on to the next bit of this question, which is really the difference between what we've seen before. And it's work out the first term of the sequence that is negative. So we know that we're subtracting. So we know at some point after quite a few subtractions, it's going to be negative. So we look at in order to find out where the first one is, we look at the positive portion, which is that positive 100. And we think of how many times am I going to have to subtract that 3 to get to my negative. So because it's minus 3n, I'm going to start thinking about the 3n portion first and think how many 3n's would I subtract to get to my least positive value. So what that means is how many 3's can I get into the 100 there. So that's the first thing I'm going to say. And I know the closest thing to 100 that is in the 3 times tables is 99. So I can then say 99 divided by 3 is 33. And so 33 there is actually the value of n that's going to get me my least positive value. So 33 times 3 is 99. So when n equals 33, it's going to be 100 minus 3 times 33, which is 100 minus 99, which is equal to 1. So that's my least positive. Now I need to find out what's my first negative. So because I'm already subtracting 3 each time, and I know when I subtract 3 from 1, that's going to get me over to the negatives. That is going to be my first negative value. So I can then go 1 minus 3 equals negative 2. And so my first negative term is minus 2. So I just started, just to recap quickly what I did there. I checked to see what's the closest I could get to 100 with my multiple of 3, and that was 33. That told me that my n was 33. And after multiplying and substituting it back into the nth term, I found that that would get me a value of 1. Subtract 3, and then I get my negative value. Okay, last one. Here are the first 5 terms of an arithmetic sequence: 3, 9, 15, 21, 27. And I need to find the nth term, and then I need to check that Ben says that 150 is in the sequence. Is Ben right? I need to check whether Ben is right or not. So first of all, I need to find my nth term. So the difference between it is 6. And so the other sequence that we know starts with 6 goes up in 6 is 6n. And to get from 6 to 3, I'm subtracting 3. And I can check that with the others. 6 times 2 is 12. 12 minus 3 is 9. So I have got the right nth term there. So 6n minus 3. Now I need to check whether Ben's 150 is in my sequence or not. So in order for it to be in my sequence, it has to be one of the positions in my sequence as I go along. So it means when I multiply one of my positions, n times 6, then subtract 3, I should get 150. And when I write it like that, I end up with an equation. So 6 times a number, subtract 3 will get me 150, or should get me 150. Now I need to find that number. So like we solve equations, I do the opposite because I'm trying to get n on its own. So add 3, but it needs to be done to both sides to balance. And so I end up with 6n, because the minus 3 plus 3 is 0. And then 150 plus 3 is 153. So 6n is equal to 153. That means n, doing the opposite again, divide by 6, is equal to 153 divided by 6. So 153 divided by 6, I'm going to do a quick bust up. 6 into 1, 0, carry the 1 over. 6 into 15 is 2, with a remainder of 3. 6 into 33 is 5, with a remainder of 3. So I can leave it as a remainder of 3, or I can write it as a fraction or decimal by placing my decimal point in, carrying the 3 over. 6 into 30 is 5. So it's 25.5. Now this tells me that Ben is wrong. Okay, now why does it tell me that Ben is wrong? Remember what n stands for? N is the position of that term in the sequence. I can't have a fraction or a decimal for a position. You can't come 1/5 in a race. You either come first or second. And in the same case, you can't come 25th, if that's even a thing, in a queue, because you're either 25th or 26th. And so it's no, because n would be equal to 25.5, and it's not a position, so not a whole number. Okay, thanks for listening.